Problem sheet 2, question 2. Consider the discrete time Markov chain below with 9 states. An arrow indicates that the probability of transitioning from one state to another is greater than 0. First, identify all the irreducible classes and state whether they are closed or not. Then, classify each state as either recurrent, transient, or absorbing. So recall that an irreducible class is an equivalence class on the equivalence relation of communication, and two states communicate with one another if they are accessible from each other. So in this case, two states are accessible from one another if there is a path from the first state to the second and a path from the second state to the first. Let's take each state in turn. So first of all, we'll consider state A. Now there is a path from A to D and a path from D to A. So these communicate with each other, and so they will be part of the same equivalence class. There is also a path from D to G and a path from G to D. So D and G will be part of the same equivalence class, and so A and G will be part of the same equivalence class. Now there are no paths from any of these states to any other state, so this must be just one irreducible class. Let's look at state B. Now, although there is a path from E to B, there is no path from B to E, and there is no path from B to any other state, so B must form its own irreducible class. Similarly with C, same story. Let's consider E. Now, there is a path from E to H and from H to E, and so they form the same irreducible class. Let's consider F. There is a path from F to J and then from J to F, so these form the same irreducible class. Therefore, we can write down each irreducible class as the set of all the states that belong to the same class. So the first irreducible class I've written down there is A, D, and G. Now, is this a closed class or not? So a closed class would mean that once we are in one of these states, we cannot reach any state that is not in this class. There are no arrows from any of these states out to a state outside of this class, so this is a closed irreducible class. The next state we looked at was B, and for a similar reason, this is a closed irreducible class. The same story with C. Now let's look at the set EH. Now for this irreducible class, we can reach state G, B, C, and J from this irreducible class, so this is not closed. And finally, F, J, this is going to be a closed irreducible class. We cannot reach any other state. Once we have written down all our irreducible classes and said whether they are closed or not closed, we should now be able to categorize each state as either recurrent, transient, or absorbing. So remember that a transient state is one that belongs to an irreducible class that is not closed. A recurrent state is one that belongs to an irreducible class that is closed and has more than one state in its irreducible class. And an absorbing state is a state that belongs to its own irreducible class that is closed. So we can go through each state and classify them as either recurrent, transient, or absorbing. State A is in a closed irreducible class with more than one state in it, therefore it is recurrent. State B is in a closed irreducible class with only itself in it, therefore it is absorbing. Similarly with C, D is in the same irreducible class as A, and so is recurrent. E is in an irreducible class which is not closed, and so this is transient. F is in an irreducible class that is closed and also has J in it. This is recurrent. G is in the same irreducible class as A and D, so they are recurrent. H is in the same irreducible class as E, and so is transient. J is in the same irreducible class as F, and so is recurrent.